Ladies and gentlemen, welcome to our fireside chat about the topic of AI at scale, removing roadblocks for industry. Now, industrial customers demand greater flexibility and faster response to changing expectations. Engineers struggle with time-consuming PLC coding, and Schneider Electric and Microsoft have teamed up to merge industry expertise with cutting-edge technology. And now feel free to join our little fireside chat between Dominik Wee, he is Microsoft's CVP of Manufacturing and Mobility, and Philippe Rambach, he is SVP at Schneider Electric and Chief AI Officer. And we will discover automation application co-pilot for PLC code generation. Sounds really technical, so let's just dive in and ask some questions to the gentlemen. Well, gentlemen, first of all, good afternoon. Welcome to the booth of Schneider Electric. Philippe, you've been here all week, I guess, already. Give us a short intro of, well, a title is a title, but what do you actually do?
If I knew, I would tell you, of course. But basically, the game for Schneider is we are here, to help our customers to be more sustainable by being more efficient. And we have been doing that since many, many years. And a few years ago, we said now that we have helped our customers to automate more, to organize their data, to visualize their data, the next step towards more efficiency is to deploy AI at scale. So our obsession is to do AI at scale, helping our customers to be more sustainable, more efficient. My job is to make this happen in a 35 billion euro company with 140,000 employees, make sure it happens everywhere.
And how does it work so far?
Extremely well.
Extremely well. Perfect. Dominik, tell us a little bit about yourself. What do you do at Microsoft?
Well, our job is to help Philippe help his customers. That's a very short version. So yeah, I lead our manufacturing and mobility business globally at Microsoft. And I think what we always like to say, we're not here to be cool, we're here to help others be cool. And like in the specific context, we have a lot of great technology in cloud and AI, but like our ambition is not to basically take it all the way to the shop floor, but to work with the companies that really understand the domain, like Schneider Electric, to make the best of our technology.
All right, perfect. So let's dive right into the questions we've prepared for you, gentlemen. Dominik, could you please share with us what are the main roadblocks encountered by industrial players in achieving their ambitions, and which ones in particular can be solved with AI?
So we look at a couple of areas. I think the most obvious one here is like what happens on the shop floor. And I think we'll be diving deeper into the whole topic of industrial engineering on the shop floor and PLC programming. So let's skip that for a moment. The other huge opportunity on the shop floor is all about what I would call root cause problem solving. I was an industrial engineer in a semiconductor fab myself at the beginning of my career, and it's kind of always the same thing. Something breaks, why did it break, how do I solve it? And then you find the guy who actually has all the data, right? It's usually just one or two guys that know how to do this, and they obviously always get asked the same thing. So what we now have this great capability, what we call the industrial co-pilot, where you can get all that data into a natural language interface, and all of a sudden it's not just these one or two people, right, that can solve the issue, but everybody has the same access to the data.
A bit closer with the microphone.
Yes, sorry. So that is the big one in the factory next to the PLC programming. But then it's obviously manufacturers don't just make stuff, they also need to develop stuff. And this is where we're also seeing a lot of opportunity. A great example is, for instance, Harting. They make connectors, and most of the connectors, they don't just come from a catalog, but they are purpose-made for a specific customer. And what Harting now does is the customer basically just describes the specification, and the AI system will generate the design of the connector and just needs to be made. And then after inventing, making, you need to sell and service. And that's the other area. For instance, we're working with a manufacturer of industrial glue. They sell 6,000 types of glue. So now you want to glue part A to part B, which glue do you use? And so what they are doing is they're building a natural language interface, so as a user you can figure out which of the 6,000 glues is the right one for you to use. And then in the service area, I mean, stuff breaks, and you usually have very complicated technical documentation. You have people like, nobody likes to read through 10,000 pages, find out like where's the problem described I'm trying to solve. So using generative AI, we can bring the right context, using a HoloLens, maybe even like in in the face of the engineer trying to solve the problem, instead of basically looking, you have the information right there.
Philippe, how does Schneider Electric actually apply AI to solve industrial customers' challenges? And to add to that, what are the primary benefits of using AI?
First, I would say that your glue customer is super lucky. He has only 6,000 references. We have 400,000 references, not counting the configurated one. So, but joke aside, different things I would say. First, and I always say it because Gen AI is wonderful and everybody speaks about Gen AI and we love Gen AI. But in the industrial world, there is a lot of problems, as the one you were mentioning, where what one could call traditional AI, if anything like traditional can be applied to AI, is very useful. Many of the things we work for customers is about detecting anomaly to understand failures. It's about forecasting. Is about optimizing. And all of that is kind of traditional AI, and that's still a big domain of efficiency for our customers when they try to optimize the yield of their production, when they try to optimize the asset, extend their life, work on the maintenance, etc., etc. So that's a big part where AI still plays a big role, and sometimes I'm afraid that people forget that because of Gen AI. Then Gen AI opens a whole new world of possibilities that you started to describe very well, Dominik. And for us and for our customers, we see two main domains. The first one is really about knowledge management. And knowledge in many ways and forms. Back to your example, one way is how do I choose among the 400,000 references of Schneider? The knowledge is somewhere in all our data sheets, in all our documentation, but hard to find, hard to understand. Or how do I solve this issue? So access to knowledge, to the thousands of documentation we have, Gen AI makes a big difference. And when I speak with our customers, many of them are facing the issue that the workforce is aging, is being replaced, and we are losing a wealth of knowledge accumulated. We are bringing to our factories a lot of new, younger employees, and we have to manage this gap of knowledge. Always in the industry, we have been looking for solutions for ages, and I think that Gen AI and knowledge management can be a really good tool to help address this generational change, I would call it, and maintain the knowledge that we are otherwise at risk to lose. So that's one of the new things being open with Gen AI, everything around knowledge management, accessing easily to the knowledge. The second thing that Gen AI brings, and is also very important, is, and here we start to touch about this solution for automation, automatic code generation, is we're using Gen AI, we can remove a lot of tedious tasks. If you have to program a PLC, program a logical controller, you can maybe remove 50 or 60% of the effort using generative AI to automatically generate code. And by doing that, we're going to, again, enable a lot of efficiency in our factories, in our customers. First, direct efficiency by being able to write more code, program more PLC, etc. But also a lot of indirect efficiency because we can build together the best AI models. We can build together the most efficiency-bringing solutions. At the end, if we want then those solutions to have a real action in the real world, we'll need automation. Which means we'll need automation, we'll need PLC, we'll need programming of PLC. And a strong barrier to the deployment of automation everywhere in our factories, in our customer factories, is the availability of engineers. By reducing the number of hours needed to program, we're going to enable a lot of improvements. So I would say, in summary, a lot of things with traditional AI to optimize our processes, optimize the energy management, reduce the energy needs, and coming with Gen AI, a new access to knowledge, and the removal of a lot of tedious tasks that people don't really want to do anymore.
Just a added question. How do you actually collect the knowledge of the experienced workers to bridge the gap between the knowledgeable workers and the new faces, like the new kids in the business? How do you collect the knowledge?
There are many different things. First, a lot of the knowledge of those people is actually written somewhere in Schneider. The thing is, they know the knowledge, but they don't
know where to look it up.
Yeah, and new people have no way to look at. So I would say 80% of the problem is already, if you're able to give an easy access to employees, to the huge amount of knowledge accumulated everywhere. I'll give you an example on which we work, which I love. We have field technicians who visit our customers to make preventive maintenance and fix eventually potential issues. They do write reports. We have maybe millions of those customer reports, technical reports of intervention. If somebody could read those 5 million reports, understand everything, synthesize it, we could provide a 10 times better support to our customers because, hey, R&D doesn't know that this is always the screw number 8. And if you just tighten the screw number 8, things go better. Using generative AI, still some work to do, but we believe we'll be able to collect all this information, all this super diffuse knowledge, in a way which will be accessible for people. So actually, you don't need to do what people think, like interview employees, but just gathering everything that has been written over the years, over the ages, maintenance reports, field intervention reports, procedures, all of that. The wealth of knowledge in that is gigantic.
Yeah, it sounds like an amazing tool in the end. Like if you've trained it, if you've collected all the data and all the knowledge, sounds like an amazing tool. A question to Dominik. How does the use of Gen AI enable engineers to reduce cognitive load and stay current in their field? How does that work?
Well, it might surprise you to hear, but at Microsoft we have a Gen AI product that's already more than 2.5 years old, right? Like this is all not just since yesterday. It's our first Gen AI product, and it's called GitHub Copilot. And GitHub Copilot is kind of what you're doing with PLC programming, just for normal programming language, right? Like Python. And it was the first product that we did. And by today, we have 1.2 million users, right? So we have real statistics. We know what it does. It's not just a vision. And what these 1.2 million users tell us is that on average, they get 50% productivity, right? This is like real numbers from 1.2 million users. And the important point on cognitive load is developers are also 75% more satisfied with their work. The reason it is like that is because of the cognitive load and because developers can stay in the flow. What they want to do is they want to code and they don't want to get disrupted because there's something they don't know. They need to go on the website, look it up, they can't find it, right? And basically what GitHub Copilot does, it brings everything into the development environment so they don't need to get out of the flow. And I think what Philippe is building is basically the same experience for industrial engineers. And what I think is so amazing about what you're doing, it's basically not just a coding environment, but you're basically reinventing the entire workflow of the industrial engineer. And I think the other piece you also mentioned that, I think the reality is most in our jobs, right? If you look at our calendar, what was the part of the work that was really fun, really creative, and really interesting? Probably less than 50%, right? Probably the biggest part of your day was stuff that wasn't that great. And it's like repetitive work. And what now Gen AI does is it basically takes these repetitive tasks away, it automates them, so you can spend time on the creative work, the work you're actually being paid for.
Sounds like a really convenient tool. I, for myself, actually use Copilot regularly to update websites and things, and it's just convenient. As you say, you stay in the flow. You don't have to, use like a search engine to find your solution. You just have it at hand and even get the code for it. So it's really, really convenient.
Thank you for using Copilot.
Absolutely. Now, next question to Philippe. Could you provide us with some insights into the collaboration between Schneider Electric and Microsoft developing the AI innovations and how this partnership, actually influenced solutions that are possible today?
Absolutely. So, again, our mission as Schneider is really to bring AI at scale to our customers, to make them efficient, to make them sustainable. What does that mean? That in that game, we bring domain knowledge, we bring customer intimacy, and we bring some AI knowledge to start from what is global and common and bring it to make it useful, able to our customers. And I will give you an example on that. But fundamentally, we do not want to do the work which is common to everybody. We do not want to train ourselves a large language models. We will not bring anything. What we want to do is take a large language model, use different techniques so that our customers can get directly the information they need about their electrical installation, their industrial installation. So the work with Microsoft from our point of view is they provide to us all the basic bricks, all the, not so basic by the way, but all the bricks, all the tools, some are very complicated, and we start from there, kind of, on the shoulder of giants, doing the next step to be able to really make it valuable for the customer, merging our domain knowledge, merging our competency, merging our customer understanding with the technique and the tools that a company like Microsoft does. And that's for the general thing. And then on a more personal thing, I have to say that the way we work together, we are able to embed Microsoft engineers working within our teams on, I would say, top of the edge and feasibility application is a real pleasure. Because whatever we all say, it's not that simple. It's not that easy. It takes some difficulty and some knowledge. You see the end, but behind that, there is quite a lot of sweat and difficulties and work. And we share that in a way which is really, really working very well, where again, each of us bring what the other don't have.
Dominik, can you share your 2 cents on the collaboration between Schneider Electric and how this work has been going on in the past time?
Schneider has been an amazing partner for a very long time, and also Philippe Rambach. I mean, thank you for the great collaboration. I think this is just the latest innovation, right, we've brought to market together. There's a lot of things across the entire Schneider Electric portfolio. I think this is what makes us work. And like, I mean, we don't have that signal from the end customer that you have. And in the end, like, as I said initially, like, our work is all about making our partners successful, right? So we really depend on that trusted collaboration.
Yeah, 15 years of collaboration together.
Already, 15 years, amazing. So I do actually have a final question for the both of you. And then if we still have time, we might even open up the Q&A for the audience to maybe ask 1 or 2 questions. Final question to the both of you. How do solutions like automation application, Copilot for PLC, code generation align with the broader industry trends and the convergence of IT and OT? And what potential does it hold for embracing AI applications in the near future?
So first, I would like to...
What a long question.
Yeah, and I will make a very long answer, so be ready. I'd like to double down first on what Dominik was saying about the tedious tasks, the repetitive tasks, and so on. In our view, tomorrow, all of us will be assisted by a kind of copilot to remove those tedious tasks. And people are always scared and say, job will disappear, we'll all be unemployed, and so on. Reality is, I think that the copilots and the AI, generally speaking, will always support us, not replace us. And the second thing, and then I'm really speaking 1,000 feet away from the ground, above the ground, is when I started to work, many years ago, it was still considered as more or less acceptable to have health and safety issue in factory. Manufacturing was dangerous, and you could accept that people were damaging their health. 25 years later, I said it now, 25 years later, it's unacceptable. Nobody carries heavy load and break his back. I wonder if in 20 years we wouldn't say, how have we accepted that people who are doing stupid stuff, damaging their brain, not their back, copy-pasting things between Excel files. So my bet is in 25 years, we'll look at what we were doing today and we're going to say, wow, they were just breaking their brain. Like today, we say, wow, they were breaking their backs. How could we accept that as a society? So that's then if I go on the ground back, on the Copilot, there will be programming tools coming from different companies. What is important to understand is if you are an automation engineer, there are very precise rules to follow because you interact with real material, with safety, with factories. So there is specific requests, specific needs, and all the aim of the technical collaboration was how can we leverage the general capacity of writing software of an OpenAI, of a Microsoft, and still blend into that the domain rules, the recommendation, the how to work that. Not easy, but working pretty well, which means that today, if you generate code using this solution, that code is at the level of what an automation engineer would do, and then he can start to refine, improve, understand, and so on. So, and I think there will be more and more of that in the general trend. And the second thing is, again, coming back to this change of generation, we have a lot of young people coming now to our factories. We need to convince them to work in factories, not an easy game. We need to convince them to work on engineering because it is needed. If we start by saying this is, like when I started, the 10,000 pages you should read, and this is this very old tool of programming, I'm not sure they're going to join the industry. If we tell them now you have 2 copilots, one to understand the knowledge, one to help you programming, and you can work in the industry and use up-to-date tools, as fun as if you're working in Microsoft, Google, or somewhere else, then as an industry, we're going to be able to attract talents, we're going to be able to do our work. So that's part of the big trend of the generational change. It's a challenge for us to attract talents in the industry, providing them with the right tools for knowledge, programming, etc., up to date and modern will help drastically.
Dominik, expecting your answer.
I love the breaking your back and breaking your brain analogy. I might reuse that if I may. So maybe to add one nuance to what Philippe said, I think it's worthwhile to dwell on the term co-pilot for a moment. And I think it's actually amazing how this world is kind of the word of the year, right? It feels like. I think there's an important nuance that we are talking about co-pilots and not autopilots. I think this is very, very important. And particularly when I speak at automotive events, people like that nuance. We're calling it co-pilot because we think of it as being a human assistant, right? And it works hand in hand with the human and is not intended to replace the human. And there's a lot of important kind of implications by thinking about it this way. First of all, we want the human to stay in the loop. We want the human to remain accountable. So for instance, we're also working with the German certification agency, TÜV. The people there, they have a lot of pride in their profession, and basically on their certification, people's lives depend on their certification, right? If you certify something to be safe, it better be safe. Their entire work is basically going through pages of words. It's a perfect co-pilot use case. But again, how, if you are that person giving the certification, how can you feel comfortable that the data, the research you did using generative AI is basically putting a position? And we would never basically say the machine is doing the certification. In the end, it's always going to be the human, right? The human needs to stay in the loop. I think that is a very, very important differentiation. And I think it's the same when we now talk about these industrial co-pilots. Basically all about everybody having a super-powered assistant, but in the same way that you would always also check the work of an assistant, you also always need to check the work of the co-pilot.
Yeah, that's why it's, and just to double down on that, that's why it's super important that those co-pilots are in a way able to do like a human would do, explain to you, this is how I did it, this is where I took the information from, and if you want to check, super easy, just open the documentation and check. That is really important for adoption.
So thank you very much, gentlemen. Dominik Wee and Philippe Rambach. Big round of applause.
Thank you, everyone.
Thanks, everybody.
Thank you.
Thank you, Felix.